This is the view of the air-cooled chiller and its single-point power junction box. You can see the 7 breakers. 4 larger circuit breakers are for the 4 mechanical modules. The bottom 3 circuit breakers are for the VFDs, 1 each for the primary and backup pump, and the bottom or 7th circuit breaker serves the C1 panel, which provides the interface to the remote control panel. This is the view from the same end of the chiller. You can see the front slave module and the front master module. Beyond that, you can see the 160-gallon stainless steel storage tank. In between the tank module and the master module is the pump module. The pumps are not able to be seen from this view. In front of the master module, you can see the remote panel. The remote panel interfaces with the C1 panel, which is also on the far end of the chiller, connected to the tank module. We'll now take a walk down the front of the array. The first module we see is a slave module. You'll notice the open space to the left of the slave board. As we pan left, you can see 2 Corel controllers. The one on the left is the master controller, and the one on the right is the slave controller. This is a close-up view of the remote panel. You can see the indicator lights, the remote master controller, and the barrel switches for pump control and the remote local capability. Now we can see the pump module with the expansion tank and the glycol mini feeder. This particular project will not be using glycol in it, so the glycol mini feeder will not be used. In the background you can see the air separator there just beyond the storage tank. We can now see the C1 interface panel, which has a transformer providing power to a convenience outlet. This photo now on the left hand side shows the dual basket strainer, and then as we pan down you'll see the dual basket strainer, the air separator, the pump module in the background. This is the first of 2 VFD cabinets, VFDs for the chilled water pumps. This cabinet is slightly different than the one to its left because of the relays that provide the pump control logic for switching from primary to standby. As we pan to the left, you'll see the second VFD cabinet, and notice that it does not have the same number of relays in the upper right hand corner. And then as we pan left, we'll see the 2 rear mechanical modules. This is another view of the storage tank, and we're going to pan to the right to review the details of the pump module. This is the inlet to the pump showing the pressure gauge. There are additional pressure taps available. This view shows the connection from the expansion tank and the braided hose coming in from the glycol mini feeder. We'll pan up to see the 2 differential pressure transmitters. Those are used to control the VFD speed and pump speed. We'll look through the pump module and find the actual pressure taps that feed the pressure input to the differential pressure transmitters we just looked at. The top of the screen, you can see the supply, the leaving the pump and heading to the chiller pressure taps. And at the bottom of the screen, you'll be able to see the pressure taps on the leaving side of the chiller feeding the building. The next view is just another look at the differential pressure transmitters. As we pan up from the pumps, we'll see 3 wires. 2 of them are thermal dispersion flow switches, the 2 with the lights on them. And then on the left-hand side, there's a wire leaving, running over to the master controller for the supply temperature input. This is the view from the both supply and return end of the chiller. And now we'll take a look down through the mechanical modules and see the variable flow valves with the connection between the header and the evaporator for each of the 4 mechanical modules. Coming into view now as we turn to the right. You see the orange power head on those variable flow valves for the 4 mechanical modules. The building that this particular chiller is going to be utilized in has a constant volume hydronic configuration, i.e. there are 3-way valves on the air handlers and fan coil units. As such, we will alter our standard configuration slightly. This picture shows a note covering the details of the configuration we'll use for this project. We will set the chiller up with standard sequencing so that both compressors in the first module would come on before the next module would start a compressor. We will assign the number of bypass modules as 3 and set the demand limiting at 75%. So essentially the 3 of the 4 chiller modules will be able to operate. Their variable flow valves will always be open, effectively operating those 3 modules as a standard constant volume air-cooled chiller.